Okay, we're back. We are in Notes 24. We are solving differential equations, and we're going to get into page 2 now. So we previously have been really just verifying solutions. Now we want to know, like, can we do this? And I think we can. So in the box here is just an example of how you separate and then integrate. So when you're doing these sorts of things, you want to get everything that has a y, including dy, on one side, usually the left. Everything that has an x, including dx on the right-hand side, which kind of effectively comes from multiplying both sides by dx, which I'm fine with. You're probably going to be fine with it for a very long time. So we need to be able to do that. This technique is going to work provided that two things happen. The first one, you need to really be able to separate. So for example, if I have something like dy dx equals x plus y, right? This is a differential equation that we saw when we were doing slope fields. It has x's and y's in it. You're never going to be able to separate this. So you might try to do something like dy equals, but remember it's parentheses here, the quantity x plus y, dx. The problem that you face is this right here, right? You have y times dx. You have to separate them and you can't. So this is not separable, and not all of them are, but a lot. So sometimes they don't look separable, but they are. This is not separable. And so we wouldn't be able to use this technique on it, but the ones that are here, you will be able to. So the first thing is you need to be able to separate. The second thing, which I mean should seem really obvious, but you actually need to be able to integrate what you get. So you basically end up with two integration problems, one on the left, one on the right, and you do both of them kind of independent of each other. The plus c goes with the independent variable always. So you're definitely, whoa, accidentally dropped my stylus there. Plus c goes on the side with the independent. Can you, nope, I thought it would become a line. Let's try again and go. Look at that. So the plus c is always going to go on the side with the independent variable. Remember that. All right, so now I'm going to do some examples, and you can follow along, and hopefully maybe you can get ahead of me. Who knows? So you know, watch the parts that you want. So first up is you want to separate. So divide both sides by y, multiply both sides by dx. So I get dy over y is equal to x squared dx. Okay, so now everything with a y is on one side, everything with an x is on another side. Two separate integral problems, you just do them. So integrate, integrate. On the left-hand side, I recognize it, right? I have 1 over y dy, so that's going to be the natural log of the absolute value of y is equal to 1/3 x cubed plus c. Okay, so we're not done because the solution to a differential equation is a function. And this is not a function. This is right now, it's an implicit relationship. We have to solve for y. So what I'm going to do is I'm going to skip like I'm going to show the steps here, but then I'm going to show you what I would have skipped because I skip a ton of steps on these and you will too. So first thing, exponentiate, right? So we're going to get the absolute value of y is equal to e to the 1/3 x cubed plus c. Okay, so this is a step that I will be skipping in the long run, but I've done it. The next step is another step that I will be skipping in the long run, but I'm going to do it this time. So the absolute value of y is, so when you have e to the a plus b, that's e to the a. So where could I write this? I'll write it over here, and I'll write it in a different thing. E to the a plus b is e to the a times e to the b, right? So that's one of your properties of exponents. I'm going to use that on the right-hand side. So it's e to the c times e to the 1/3 x cubed. Okay, so I would have skipped this step, and I will show you how I would have done this problem soon. Now, if the absolute value of y is equal to the right-hand side, then that means that y by itself is equal to plus or minus e to the c times e to the 1/3 x cubed. Okay, but what is plus or minus e to the c? It's just some random constant that we don't really know. So here I would say, therefore, y is equal to a new c. So I just call it c again. Some people will call it c sub 2, totally fine. Some people will go from like c to k. It doesn't really matter, or a or whatever. I choose to just keep using c. And so this, I would have, if I'm being totally honest with you, I would have jumped straight from this step to this step, and I would have skipped, and you're allowed to. You can skip these steps. You should know what those steps are, but you can skip those. The reason you can skip them is 100% of the time, it's going to happen that if, where are we here? Let's see. If y is in a natural log, skip some steps, because it's always going to work out the same. So, and as we do more of them, I'll show you, and I'm going to do it, and I'm going to reference back to this and be like, these are the steps that I was skipping. So I'm going to skip them every time. So that plus c that's on the right-hand side initially becomes a coefficient c for the exponential function that you get. That c, this coefficient c that's here, could be positive, it could be negative, so I don't need this. And it just like, and at the same time, simultaneously, the plus or minus, you also drop the absolute value, and it saves you, I can't write, saves you a ton of time. So as we do them, you'll see I skip that step every chance I get. All right, let's try this one. So dy dx equals this. So first we're going to separate, then we're going to integrate. So get everything with a y on the left-hand side. I'm going to get y dy. Everything with an x on the right-hand side, I'm going to get, what am I going to get? 3x squared dx. Okay. Now, everything with the y's on the left, everything with an x on the right, two integrals. Integrate, integrate. All right, on this side, I'm going to get 1/2 y squared. There should be a plus c, but we save it and put it on the same side with the independent variable. So equals x cubed, and now our plus c. Okay, is this a function? It's not. This is still like an implicit relationship. So we have to explicitly solve for y. So what I'm going to do, I'm going to multiply through by 2, get y squared is equal to, so 2x cubed, 2 times c, 2 times some number that I don't know, is just another number that I don't know. So I'm just going to say plus c. These c's are not the same c, but it doesn't really matter because we're not going to solve until the end. So not the same. In fact, the one in the second step is twice the one in the first step. Doesn't really make a difference for us. And as you do more problems, you'll see, and you'll get more comfortable with that. But it's a thing that basically everyone does. If you don't like it, make it C2, right? The thing you don't want to do is you don't want to really write 2 times C, because C is some unknown constant. 2 times an unknown constant, just another unknown constant. We still haven't solved for y. So now we're going to say y is equal to, so plus or minus the square root of 2x cubed plus c. Now, are we done? We solve for y. We are not yet done because, so we're not done. Y is not a function of x. If I give you an x value, you'll get 2 different y values. You get the positive one and the negative one. So here's what you're going to do. And this is a little bit different. So you are going to say, here we go. Okay, y is equal to the square root of 2x cubed plus c if the y value of the initial condition, I don't know, satisfy, if let's do this. Let's say, so I'm having trouble verbalizing this. Basically, if the y value in the initial condition is greater than 0, if y is greater than 0 in the initial condition. So like, say you were given, for example, if y of 0 is 8, you would have to pick the positive square root because you need to get positive values out of your function. Similarly, say therefore y is equal to negative radical 2x cubed plus c if y is less than 0 in the initial condition. So for example, maybe I should be saying like e.g., I think. IE and e.g., like I hate both of those. One of them is like in explanation, not really, but like that's like what the English version of that is. And the other one is like example, not how example is spelled, but e.g. feels like how you could misspell example if you wanted. For example, if y of 0 equaled negative 10, right? You'd need to be able to get a negative out of there. So you're going to make a choice. There's a lot of choices that you have to make along the way. So each of these problems so far has had its own like little weird kind of thing to it. So in part A, I'm telling you that you're going to skip a lot of steps. But we don't know that yet because we haven't done a lot of them. But we're going to do it. We're going to skip a lot of steps in part A. In part B, you have to get a function as your answer. So plus or minus is not going to do it. You're going to have to pick if it's positive or negative, but you just pick it so that it goes through the initial condition. Like it's not really the hardest choice that you're ever going to make. So what I'm going to do is I'm going to cut this video here and come back in the next one, finish this page. We'll see what's going on. So I will see you then.